Hey, Ian, how's it going?
Not too bad. How about yourself?
Not too bad.
How's it going, guys?
Good. How you doing, Zach?
Pretty good. A little sick, so I'm
Uh-oh.
hard to understand. That's why. Luckily, it's an online meeting, though, right?
That's right. So if you sneeze, you're only damaging your screen.
That's right.
Is Austin joining us tonight?
Yeah, he's at his place still.
Okay.
He'll be on in a minute.
All right. Sounds good. We need to do well on this quiz. I'm in desperate need of a good score.
Yeah.
Yeah, I made a couple of dumb errors on the homework on last week.
Well, me too. I actually just rushed through it because I was in a hurry and I forgot about it.
Uh,
Yeah, I just didn't do it.
yeah.
I'm really tricked Utah that I sucked up that time.
Yeah. Hey, I'm having a little hard time hearing you, Jared. Can you turn up your mic a little bit?
How do I do that? My there's really no volume for it.
Okay.
Is your volume turned up?
Yeah.
Oh, please. Volume.
That's better. Hey, Austin. All right, should we jump into it? Maybe
Yeah.
the other Jared is coming along.
Well, it is 9:01, so
Yeah, maybe we could wait a minute or two.
can't wait.
I'm just so excited to get this homework rolling.
Okay. Nothing better to do than go to the math homework.
Absolutely. Wonder how much these videos Sister Cook watches.
Yeah.
Hope not too many of ours. It's a little sarcastic sometimes.
Yeah, she'd die of boredom.
Especially about the homework in Excel and SPSS.
Yeah.
Like, hey, I like that program.
All right.
It makes one of us.
Maybe she plays all at the same time.
On different monitors.
Yeah.
It just like opens it and you're like, yep, it's there.
Yeah. Hey, Austin, how you doing tonight? You're looking kind of serious. Everything all good?
Yeah, I'm just reading through back over the stuff. I've been trying to build an Excel sheet to calculate everything again.
This week's stuff, or are you going back on the homework from before?
This week's stuff.
Okay.
I have like a really rough version of last week's, and I haven't really bothered to make it any better because we
Sure.
had our exam on it already. So
Yeah, I hear you. Yeah, I have a fairly rough one today for today's stuff. Well, should we jump into it?
Sure.
I'll take number one, the confidence interval. What is a confidence interval? It's basically a range or I guess an interval of numbers where a parameter of a population falls, and that confidence will be based on the percent of confidence that you have will determine the interval, determine the range.
Right.
mm-hmm.
Okay. Somebody want to
Yeah,
take
I can
two?
take that. I can take the second one.
All right, cool, thanks.
Okay, what is the margin of error in a confidence interval when estimating a population mean? So it is like, it's the percent, it's kind of like a value put to the probability that it's wrong, and like the amount, it's almost like the percent change in it. So it'll either err, like an example would be like the 3% and then the voting polls. So it's
Yeah.
either going to be 3% over or 3% under. And your confidence interval is the numbers in between that. You're confident that it's within those limits.
Yeah.
So, yeah.
So
I don't know if there's any more to that.
in my head, it's kind of similar to probability. Is that kind of right? So you're 95% confident that all of the numbers are going to fall within that range. Does that sound right? Is that similar to probability in your head, or should I think of that differently?
Yeah. I think it's dependent on what the margin of error is, but
Right.
yeah, it's about 95%.
Yeah, I mean that can change depending on what, how confident you are. Whatever margin, Yeah, okay. I think we got it. Anybody else want to add some more confusing stuff?
Oh. You could just read the answer.
Hey, that's a good idea.
Yeah, I'll do that real
margin
quick.
of error. Yeah.
Margin of error is half the width of the confidence interval. It is the distance between the point estimator and the one of the bounds of the interval. If you have a large margin of error, then your confidence interval is also large. So if you have a small margin of error, your confidence interval is small. I think it just wanted like the very simple explanation, not like the numbers behind it, sounds like.
Yeah. The large confidence interval kind of threw me. I was thinking that if your confidence interval would be large, then you'd have a smaller margin of error. But your confidence is you're looking at a bigger percentage of the data, so you have to expand that range in order to get all the numbers in the middle.
Yeah.
Well, it's kind of like if you're about to pick a stock out of your drawer. You have like a bunch of different colored stocks. You don't know how many are in there, but you're like 50% sure there's at least one black. But there's just that one pair of randomly pink stocks, and you have no idea whether or not. And you can be like, well, I'm 95% sure that there's either a theme tone. Like it's just like the greater the confidence interval, the more colors you have to put in.
Yeah.
Because there's no idea. And well, the more numbers you have to that confidence interval, the more confident you are that stock is there. Kind of a weird analogy.
Yeah, I like it.
Assuming you know sigma, the standard deviation, what is the general formula for a confidence interval used to estimate the population mean? And that would be the sample mean plus or minus the margin of error, which is the confidence interval times the standard deviation divided by the square root of the sample size.
Yep. Okay.
Number 4. What are the assumptions for creating a confidence interval for a single mean sigma known? 2. A simple random sample was drawn from the population. The distribution of the sample mean is normally distributed, and sigma is assumed to be known. Those are the three
Okay.
assumptions.
Well, yeah. So you don't need to know the population size, or you don't need to know. There was another thing that you didn't need to know. But that's, yeah, I'm just thinking out loud, sorry.
No worries. Okay, the probability applet. So if you type in a 0.9 in the probability applet, you get a z-score of 1.65.
Yep.
0.9?
I'm sorry, 0.165?
Or 1.65?
Yeah, that's the 0.9. I'm sorry. Yeah, the 0.95 is a 1.96.
And then the 0.99 is 2.58. And then the z-score is the area in the middle. When the normal curve increases, the z-score will also increase.
Okay. All right. Any questions about part 1?
Mm-hmm.
All right. Part 2. Moving on. What are the 3 assumptions that need to be checked before you compute a confidence interval for the mean? Didn't we already ask this?
Yeah.
Yeah.
You have to have a simple random. It has to be normally distributed, and you have to the sigma is assumed to be known. Oh, that is slightly different, isn't it? No, it's not.
Pretty much.
It's
Yeah, it's the same. Okay. All right.
the same for both of those scores. The graduate management admissions test is used as an admission criterion in many Masters of Business Administration programs. A BYUI professor would like to estimate the population mean from a simple random sample of 50 people's scores. The sample mean for these 50 students is 541. Assuming a population standard deviation of 32, assuming or answer the following questions. What is the point estimate for the population mean? So 541 for that. Also says we use the sample mean to estimate the population. Since the sample mean is 541, this is the point estimate population mean.
So we're doing a 95% confidence. That's the 1.96. And the standard deviation. Wait. Standard deviation.
So, okay. I made another calculator, of course. See, so the 95% interval, 95%,
What am I doing wrong here?
5.1, and so 39.9. Yeah. So, yeah. All I gotta do is, take the standard deviation divided by square root of 50 times the critical value of the z, and then plus or add and subtract it from that end, and that will be your margin of error. And yeah, and then you'll take the lower end and the higher end,
Oh, the X
and
bar.
that will be your confidence interval.
Okay. Did everybody get that for number 8? Anybody still working on that one? 532.13 and 549.87.
Yeah, you just add
Yeah.
Add
Add the
standard
margin.
deviation twice, right?
Yeah.
Or once and then
And then
subtract it
subtract
once.
once. Yeah.
Yeah, I'm building
the
the one.
margin. Okay.
I actually built a thing like this on my other one to just calculate it and put the percentages, and it might be a nifty little function if you guys are interested in doing that as well.
Yeah. Now, if the sample size changes to 100, we just key that value in, and now it changes to 34.73. So the new margin of error is 6.27. And the bottom number is 5.4. I'm sorry, the lower number is 534. Top number is 547.27.
The margin of error for the 95th percentile, or the 95th confidence interval, of the sample size 50 compared to that of 100. So the 100, the sample size for the 100 is a larger, let's see, margin of error.
So when you have a bigger sample size, the margin of error goes down.
Oh yeah, margin of error. I don't know why. I was thinking of the size of the confidence interval.
Yeah, and when your confidence interval increases, your margin of error increases. But the sample size is the opposite.
Yep.
Okay. Everybody, does that make sense, everybody? Zach, you okay with that?
Yeah, I think so.
Okay, so then 11 is a 90% confidence interval for 50 students. So we're going to use the 90%, which is 1.645. So that's 533.56 and 548.44 on the top end.
Yep.
So number 12.
Sure.
How is the margin of error for the 95% confidence interval that you computed in question 8 compared to the margin of error for the 90% confidence interval that you computed in question 11? One in question 11 is bigger. Well, the first number is actually. They're pretty close. The answer says, remember the margin of error is just the second part of the equation. Therefore, in comparing the two margins of error, the margin of error for a 95% confidence interval is 8.87, while the margin of error for a 90% confidence interval is 7.4. Margin of error gets smaller as the level of confidence grows smaller. Okay, yeah, that makes sense.
Okay. I have a little a spreadsheet for the sample size.
You want to share it?
Sure. Let's see what we got here. Can you see that okay?
There we go.
Okay. So I just have this formula set up here. So we're pulling the z-value multiplied by the sigma divided by the margin of error squared. And so the z-value for the 95% is 1.196. Sigma, I think, was 32. Is that correct from the question? And it also said he now had a margin of error of 5 and wanted to calculate what the what the sample size needed to be. And so that's 157.35. But you can't have a half a person, so we always round up to the next whole number.
Okay, right.
So that's where you get 158. That make sense?
Yeah.
So you took the z-value times the sigma divided by the margin of error and squared it all.
Yep.
Yeah.
Gotta love Excel.
Absolutely.
Not SPSS.
Okay. Should we move on to the quiz, or is that the bottom of the homework? Yeah.
Ooh.
Hey, Jared.
Hey.
Do you want to go back over any of that stuff that we were talking about?
Oh, it's okay. I'll reread things.
Okay. We're going to jump into the quiz. You guys okay with if we do that?
Yeah.
I actually got a question real quick. I think I just may have blanked on this. So, in order to find the z-value for that one, you took the 95%, so you typed in 0.95.
Well, actually, I didn't type it in. I just used the known confidence value for 95. So they're kind of given numbers. If you're looking for 90%, then the z-value is 1.645. If you're looking for 95, then it's 1.96, and 99 is 2.58.
I see.
It's just the z-scores of those probabilities, 0.9, 0.95, and 0.99.
Gotcha. Okay.
Yeah, I didn't calculate anything. That was just a known value. Any other questions? Did that make sense, Austin?
Yeah.
Okay.
For some reason, I just forgot that we had drawn those up earlier.
No problem.
But it makes sense now.
So my guess is the next next section will be having us calculate the z-score and then plugging that in. But, I don't know, maybe not. Since we know how to calculate a z-score,
Yeah.
they could give us a little bit less information and we could still figure it out.
Okay. Quiz?
Quiz it is. All right, so question 3 says, does everybody have it open? So they want to know the 90% confidence interval when the standard deviation is 50 and the sample size is 25. So the z-value for 90% is 1.645 and the sigma is 50 and the n value is 25. So I come up with 16.450. Does that sound right?
Yep.
Jared, are you calculating this too?
Yeah.
Okay, sounds good.
Yeah, I'm actually on question 7 now, as you've been chatting.
Oh, you're just
Yes,
leaving us
so I
in
can-
the dust. All right, so what'd you get for 4? Let's see.
X bar, the point estimator of mean.
Of the mean? Okay.
Yeah. I think that's population mean, right?
Yeah.
Yeah, that's right.
Okay. Does anybody want to read 5?
What was number 4?
The X bar is a point estimator of population mean.
Which is mu, right?
Because mean is the unknown thing, and so the other way around wouldn't make sense. Okay.
Right.
And then what was 3? I was trying to put something together on my calculator.
Oh, sorry. We have a 16.450.
Okay, thank you.
Mm-hmm.
I can read number 5.
Cool.
Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation equals 113. She collects a simple random sample size population 64 and computes population mean to be 526. Uses information for questions 5 through 8. What is the lower limit of this confidence interval? Round to 3 decimal places. Lower limit. 95% confident.
So you're going to use 1.96?
Yeah. Sigma is going to be 113. The n value is 64. And the x bar value is 526.
Okay. So wait, what equation are you using for this? You take the... You're
Yeah,
taking
I can share my
the
screen.
z-value?
Yeah.
Okay. Z-value times the standard deviation
Can you guys see that okay?
Uh-huh.
Okay, so what I'm calculating first is the margin of error. So the margin of error is the z-value times sigma divided by the square root of the n value. Is that right? Jared, is that how you're calculating too?
So what are we on?
Sorry, I was just answering Austin's question about the question number 5, how we're calculating that.
I would just plug it in my calculator.
Okay.
I'm playing
So-
dumb today. Number 5, so let's see, lower limit comps. Okay, so all you do is you find the margin of error. So you're going to take this, let's see.
So we have the
We're at
z-value.
95. Yeah, 95, the z-value is 190, or 1.96.
Yep.
And you'll times that by the standard deviation of 113 divided by the square root of 64, which is the sample size. That's your margin of error. And I have that as, oops, sorry, I'm not on Eclipse anymore. So I don't know what it is, but you subtract it from the sample mean, which is 526, and you get 498.35.
Okay, so yeah,
when you add it to the mean, you get the higher end, which is 553.685.
yeah. So the margin of error I came up with is 27.685, which jives with the rest of Jared's numbers. Does that make sense, Austin? So the answer for number 5 is 498.315.
Okay, my calculator's not working. So that's why I was trying to figure out what I did wrong.
Ooh,
Was that 0.315 or 95?
315.
315.
Okay, so then margin of error divided by, or then you add or subtract that. First,
Yeah.
we're just subtracting it.
Yeah,
Twice.
you add it for the upper bound. You add it to the x bar value to get the upper bound. You subtract it from the x bar value to get the lower bound.
Okay. That's what I did wrong. I had my thing all set to the standard deviation and not
Oh, not
the margin of error. That's
Okay.
why.
Yeah, okay.
So I got, for the lower bound, is 287.315.
Sorry, what did you say? The first 3 numbers?
287.
It's 498 because the x bar value is 526.
526.
Subtract that from
Oh,
520.
I see. What? Why
Yeah,
is that?
that's given in question 5.
Oh, that's dang it! I didn't change my. Okay, so 498, 315.
Right.
4. This is very disorganized in my thing right now. I've been doing like the mean wrong and then the X bar and everything all flipped around. So, and the upper limit's going to be 553.685.
Yeah.
Okay, so what would happen to the width of the confidence interval if Gina increased the sample size?
That would
So the
increase
increasing the sample size is going to decrease the confidence interval?
Should, yeah.
Yes, should.
So I just added 100 to the sample size, and that tightened things up. So it's going to decrease the confidence interval.
Oh, okay.
No. Okay, what happened? The confidence interval. It's 299. It's going to be 2.58.
So that should increase the confidence interval.
Yeah, if you increase the confidence interval, then the
Yeah, if we
interval gets
increase
bigger.
the percentage,
Yes, the
confidence.
percentage.
Yeah.
Okay.
Okay.
I'll take the next one if you want.
Okay. Number 9.
Yeah, light bulb companies trying a study to assess the average life expectancy of the light bulbs. They know their standard deviation is 400 hours, and they want a 95% confidence interval with a margin of error of 50 hours, and they want to know what the sample size should be. So, using the equation, I believe we're going to we're going to take the M11, the critical value times the standard deviation divided by the margin of error, and then we're going to square that, and that'll give us this sample size. I have 246.
Okay. That's what I got too.
Shoot. $200, 246?
Yes.
Okay, that's what I got. And you need to round to the nearest whole number?
Yeah. I actually got 245.86, so I rounded it up to 246.
Yeah, that's what I got as well.
All right. Sounds good.
Perfect.
So 10, the mean salary of actuaries is $100,000. Maybe I should look into becoming an actuary. And the standard deviation is 36.730. You're interested in knowing the mean salary for women actuaries. Oh, if the mean salary for women actuaries is different from the population mean, but you're not sure if it's higher or lower, you set up a hypothesis test with a level of significance alpha of 0.05, and your null hypothesis is that the mean average is $100,000, and your alternate hypothesis is that it's not $100,000. You collect a random sample of 36 women's salaries and find that X bar is 111,000. Use this information for question 10 through 12. Okay, so you're setting up an alpha of 0.05, so the z-value is 1.96. Is that right? And you have a mean salary of 100,000.
I think we're supposed to use the sampling window. Right?
Say that again.
Are we
Oh,
supposed
you're
to
right.
use-
Yep, I'm sorry. 111,000.
Yeah.
Okay. And then the sample size is what now? 36?
36.
Okay.
Mm-hmm. We want to find a 95% confidence interval.
Yeah.
So 1.96.
Yep.
Okay.
So I have 99,000. Oh, let's see. Round to the nearest whole number. Let me see what this is. $99,002 for the low.
Uh-huh.
Okay. And the upper is 122,998.
Yep.
Okay.
122,998.
Yeah, that's what I have. Is that what you got?
Yeah.
Okay.
And then, yeah. 99001. Okay.
Okay. 12's a weird question. There are 3 requirements that need to be checked when computing a confidence interval of a mean.
All of the above.
Isn't that the only answer possible? If there's 3 requirements?
Yeah.
Or is that a trick question? Am I missing something?
Wow. That's
They
definitely
are. No, because you need to know the standard deviation, and then you need to know the mean of the sample. You don't need to know the population mean,
Right.
and the sample
Mean has to
drawn
be.
from a population.
Yeah. I
Okay.
just it's the right answer.
Okay. Are we done?
Yeah.
Mm-hmm.
Are we submitting?
Yep. 100.
Sweet. All right. Well, that's what I like to see.
Yep. Thanks, guys.
Yep.
Yeah.
All right, everyone have a good evening. We'll see you guys on Thursday.
Yeah. See you.
Me too.
I'll send you your stuff, Austin.
Thank you.
Yep.
Bye.
Yep.
Good night.